let's go through a complete example now where we have to construct a confidence interval. Mrs. Stolzfus is curious what percent of Pequea Valley parents would support an increased tax rate to build a new high school featuring windows for her classroom. So you could certainly ask every parent, but that would be a census. So how could we use a sample to make a prediction? She randomly selects 80 parents, and 34 respond that they would be in favor of a tax increase. First, show that the conditions for calculating a confidence interval for proportions are satisfied. Again, you don't need to memorize these for this course. Simply refer to your notes and apply them to the situation. So the first is, statistically, to do this process, your sample must be random. So I put it into context. 80 parents were randomly selected. Next, we have the 10% condition, which says our sample must be less than 10% of our population. So maybe this is doing a little bit of an assumption, but I would say 80 parents is less than 10% of all Pequea parents. Right? There's probably 800 parents in the entire district. And our third condition we used before, whenever we want to look at a normal distribution, we need to have at least 10 successes and 10 failures to have a approximately normal sampling distribution. So this is where, do I have at least 10? Well, I'm going to say 34 parents voted yes. All right, so how many would have voted no if there were 80? So 80 minus 34 would be 46 parents voted no. And I can say both are greater than or equal to 10. So I'm good. Now, sometimes you will actually do n times p hat, but you're doing that to get the counts. So if I have the counts, I'm just going to use them. So 34 and 46. Now we're going to actually calculate our 95% confident interval. So I'm going to write the general formula. It's your observed, your p hat, plus or minus your margin of error. How do we get the margin of error? Formulas on your paper. You're going to do your critical value for a 95% confidence interval times the standard deviation, which is p hat times 1 minus p hat over your sample size. So what's my p hat in this problem? It's what I've observed from my sample. P hat is 34 out of 80, which is 0.425, okay? So that's what's known as my point estimate is 0.425. That's like an estimate of how many parents, out of the 80, of course. So I would expect the population, since it was randomly selected, to also be about 42.5%. But I'm going to add and subtract my margin of error. How do I statistically calculate that? I'm going to use my critical value. For 95%, we've repeatedly seen that it is 1.96. You can, if you've forgotten, quick reminder is you do inverse norm. And this is where you put in your area of 95. Sorry, my stylus isn't writing. That should be 0.95. Mu is 0, 1, and center. Okay, so if you haven't done that process, just quickly verify on the calculator that it is 1.96. And then we do times the square root of p hat. We just calculated as 0.425. So that's the percent that vote in favor. So what would vote against would be the complement of that. So 1 minus 0.425 would be 0.575. All over my sample size. Well, we asked 80 parents. So what I want you to do is you're going to type this into your calculator. Now, you can do it all in one step, like where you add 0.425 plus all of this, and then just kind of use the copy and paste feature and change it to minus. I have it in 2 steps. Please pause the video, though, and actually practice. So my margin of error, when I type in, everything here that's highlighted is the margin of error calculation. That is 0.108. So that's like 10% that I'm adding on and subtracting from if I want to be 95% confident that I capture the true proportion. So when I do that, let's see, subtracting it gives me 0.317 and 0.533. There's my interval. Now let's interpret that. And my interpretation is that standard statement I gave you. I'm stating I am 95% confident that the interval from 0.317 to 0.533 captures the true proportion of Pequea Valley parents who would vote to support a tax increase. Okay, you'll occasionally see people change these to a percent. If that's easier for you to talk about and interpret, you could make it between 31.7% and 53.3%. Okay, but if you talk percents and you don't put a percent sign, I'm not guessing. I'm going to assume you're incorrect. Okay, I keep things in decimal form and then I don't have to worry about dropping a percent symbol. So there is a complete example of how you build a confidence interval for proportions. Your turn to practice.